So that's her job to do that. And the really good testers and quality assurance people, they go through and they can get all that kind of stuff and they figure that out. So it's kind of a big deal. Again, user enters data, program attempts, math errors. Math errors are kind of a big deal. That causes problems, and that's one of the examples in the book too. Um, so again, you get an exception. The whole idea behind this is it does what it just throws this exception, and it's got a nice way. Java has every language has their way of doing it. This is how Java does it, and it's very, other languages are very similar. They do their own try catches, C, C++. In this case, there's an error class, which actually you can represent different errors. So you can actually be very specific when you throw an error, and you can tell the user exactly what the error was. You can make your own customized errors. You can do all that kind of stuff. What happened? Why did it crash? Did you run out of memory? Did something not happen? Blah, blah, blah. So here they have an example here where you're doing a division. Kind of just show that. It's in the book too. You're trying to divide something. Yeah. Okay, 12 divided by 4. Beautiful. Works great. But then you do something else and a math issue, and then you get arithmetic exception error, divide by 0. Now, there's nothing wrong with that. It's not programmatically, it's fine. As long as you catch it and you would tell the user nicely and say, listen, you're dividing by 0. That's going to cause a problem, right? Or you don't let them enter a 0. Denominator, enter anything greater than 0, right? Maybe you get it, catch it at the big thing we always talk about with when a user gives you data or you're getting data is try to catch at the source. Garbage in, garbage out. 0 is not necessarily garbage, but in this case it is because if they enter a 0, it's going to cause problems, right? So you say, please enter anything greater than 0. If you're working on integers, obviously that means it'd be like a 1, 2, 3, whatever the case may be. And if you want to do negatives, you can do that. But anything that's not going to do that, so you got to dictate that. And even though you tell the user that, right, you have to go in and you still have to make sure that they do that. You got to check if did they enter this, pick your range, all that kind of stuff. So it's that saying trust but verify, right? Trust that they're going to do that, but then verify that they do that because they may still, again, not intentionally. There are people that do intentionally try to break things, but then there's people that don't. Hackers do that all the time. They go on websites, they get applications, especially on websites. This is more of a website issue. They try to just enter garbage. They play with stuff. They see if they can break your website and maybe get in where it errors out, but then all of a sudden you're in a debugger or you're in an area where the normal person doesn't get there or they don't know what to do. They're like, what is this? And the regular person would probably just close a browser or whatever. Whereas if you know what you're doing, all of a sudden you're on the system kind of behind your you went behind the curtain, right, to see what's going on, and you can cause lots of problems, and you never want that to happen. We don't talk about it much in this class. You talk about in databases or something called you guys ever like SQL injection. That's kind of a big deal. People would enter, and what that is you're entering a SQL command, literally like on a command line. They put this whole line on one command line. And sometimes they'd put some things like delete tables, delete databases, to try to figure out what you even have in your system. And some hackers just do this just to see if they can do it. They're not malicious about it. They've got nothing else to do. They're like, wow, I'm on this system. Let's see what I can do. And they're not realizing that you're just screwing up all the systems. Obviously, these days, that kind of activity is not good. It's frowned upon, and you can be arrested. So just be careful. Careful about how far you get. You don't have to necessarily deal with the exception. You can let the offending program terminate, like it says. But again, you don't want to just have it stop and blow up. Usually you want to put some type of message, give the user, because what's going to happen is if you write an application and it goes out there, and all of a sudden some error comes up, you want them, if they're going to call the help desk or tech support or whoever it is, you be able to relay some type of information if that's your program, right? I'm working in this accounting application and it just shut down. Well, what were you doing? Well, I was entering debits and credits. I was doing some billing and then it just blew up. And you tell them about did you get an error? No, it just stopped. All right. So that the help desk or tech support people are going to be like, I don't know. Whereas if all of a sudden you get an error on line 310 in your code, it did this or that, that's extremely helpful, right? You can do that. If then you write to a log, we talked about writing to files. If you give an error on the screen that they can maybe do a screenshot, nowadays everybody will take out their camera, their phone, right? They'll take a picture of the screen hey, I got this error. What does this mean? I have my own students do that. They just take a screenshot, which is beautiful. I say do that. If you're never sure and you have an error, just take a screenshot of it and send it to me, and we'll walk through it. Hey, I got stuck here. I don't know what's going on. And then right away when I can see it, it makes sense to me. So those are things that are very helpful. Um, Again, you can write programs without using exception handling techniques. And the way to do that, some of it is you kind of preempt it and you kind of make a decision. So like I said before, if you want digits, you have a menu system, kind of like talking about like for final projects, and I'm asking you to enter number 1 through 5. And you make it so they can only enter 1 through 5. If they enter anything less than that or greater than that, it won't accept it. If you say it's got to be like is num, you make sure is it a num, then it works, things like that too, right? Um, those are ways you preempt it. Again, you get it at the source. You stop them right away from entering anything bad or whatever the case may be, and they can't do it. And if you do that, then you're kind of not having to deal with some of this stuff, which is kind of nice. There's a bunch of things that you can look at too. It gets a bit more involved. Is like a stack trace, and what this is, you're tracing, and you can do this in part of debugging. When you get really much more involved in debugging, you can trace. All you're doing is tracing the code of where it went and when it went wrong, and you're tracing the stack of what the calls were. Maybe it was in the middle of a call to something, to an API, to another program. It was trying to open a file. It was trying to get something out of a database. Who knows? It could be anything like that. The big issue, though, is depending on what your application is, how critical it is. Like it says, is it mission critical? So is it something that if traffic control, yeah, that could be a big deal. Banking systems, investment systems, healthcare systems. I kind of joke all the time saying, and it's not really a joke. It's actually partially injustice. I never really wanted to write code for both either healthcare or financial. I never wanted to kill somebody, and I never wanted to have someone lose millions of dollars. Not that you would anyway, because even the healthcare systems, I did actually write applications for a healthcare system, and there's so many checks and balances along the way, and there's what are called HIPAA rules and things like that, where they check everything. I was a consultant at Abbott Labs for a bit, and they check everything with a fine tooth comb because they are regulated by the FDA. And so there's just so much they have to do. If you work in the financial industry, I'm sure you've got certain sets of regulations that you have to do. Do you have to do that at the credit union? Are there certain probably regulations, things like that you have to worry about? Not really. It's like the Wild West. Fault tolerance, kind of what we were just talking about. I know I cut the recording here. Design. So if something happens, if one part of your system or program fails, can it keep going? So if there's a certain part of it that doesn't work or anything like that, can you keep going? How resilient is the system? Things of that nature. So there's a lot of different things. Again, depending on what you're doing in your system, there's a lot of different things you could or couldn't do. That's kind of important. Let me go to here. Let's go here. So exception handling is what we're doing. This is about the different things we talked about. The PowerPoint drive me crazy. Okay, so here's the sample we were just talking about there. And then you get the errors, all the different types. So again, as long as you catch these are errors that you just don't want the user to have to deal with, because they're not going to know what to do with them. Most people are not going to know. But so then, boom, right away, a way to do this without a try exception, you can say, so again, if the denominator is 0, then you give them a nice little message and say, hey, dude, you can't divide by 0, or do that or whatever. And then you've got the result, and otherwise it'll process and it'll keep going through that. That's all that's happening there. So I think this is even if you're doing a try catch, I think this is still good. You can never have enough code built in to potentially prevent that. Even sometimes if some of it doesn't run, at least you've got it in there. The last thing you want is your code to just kind of choke on you. So we get into try code and catching exceptions. Try and catch. It's called a try block, is what it is. And it's again, every language has some variation on it. If it's an object-oriented program, again, it's a procedure, and all it does is it detects if there throws an exception. So the try means you're trying this code, and I'm going to run this code, And if something happens, then it's going to catch. It's going to catch whatever gets thrown, some error messages or get thrown here. So here's a very simple example, right? I'm going to try, I'm going to execute some statements here that's going to do something. I'm going to look at a database, I'm going to open up something, that kind of thing, whatever the case may be. If for some reason something chokes, it doesn't work, boom, it jumps down to the catch, and then you can even explain what's going on in the exception. And we'll do some of this as part of our thing. So here's some real code. Again, here's the denominator one. You do the division. It doesn't do the check at the beginning to see if the denominator is 0. It doesn't care. It just goes right into the try. Open curly, and then it's just your plain old code. All you're doing is wrapping your regular code in with these try and catches. And in the catch, you're saying, hey, there's been a problem. So this is the class. The arithmetic exception is a class, and it passes and it throws the mistake. And so you can actually print out the mistake. You can put this is your own error message right here. This arithmetic, blah, 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 that's wrong caught. And then you could do like a colon and actually put in there the mistake of what, right here, of what the actual computer generated, the system, what it returned to you, because it will return actual error code. Sometimes it might be helpful. Sometimes it might be more confusing. If you just want to do your own error return like they did here, that's fine too. Some shops, some places that you work, they may have their own standards. There's places that have their own what's called an error class, where they literally will have it so that if you have any errors in your program, you're supposed to call this class. Think about it in the web world, in a web application. A lot of times if you have an error, what's the error if you go to a website you can't get it? Can't find the web page. 404. Right? That's probably the most common one you'll get for some reason. It doesn't mean it necessarily is not there. Maybe your connection's bad, whatever the case may be, because sometimes I've gotten 404s and then I'll refresh and boom, there it is, right? Maybe it was a hiccup. But oftentimes if the page is not there, you'll get like a 404, right? That is a standard error. Well, a lot of places just like to do something nice where even if you're on their domain, so if I'm on Gateway's domain and I try to get to and access a page that's not there, it might still be like a 404, but it might be nice. I'll still see all the gateway stuff around it, and then it just might have a little error message there. So they kind of surround it that way. There's a bunch of different things you can do. You can still have your company header and all that in the footer information. And if you feel you've reached this page in error, I'm on an error page, please contact technical support, whatever the case may be is. So here, let me, you know what, I know this is a web page, but let's just do this. Let me do gtc.edu just for the heck of it. And I'm going to do something that I know shouldn't be there. I'm going to see what happens. Is it just going to choke on me or what's it going to do? Yep. So I get a page not found. It's their version. It's Gateway's versions of a 404. Gives me a page not found, but everything else is still here. It looks nice, right? I still have my header. I have my footer. I have all the content there. And it just says page not found. So it's a nice error message. It says, yep, you just look for something that's not there. Because I forced it. So it intercepted it and it said, okay, versus just getting like literally an empty screen at 404. And that's all I was talking about. That's kind of the idea behind it. Is it perfect? You know, I don't know if there's anything that's perfect, but this is a nice way of handling it, doing it that way. So again, in this case, this is back to Windows programming. This is the way we can do it here. Again, you can do the try. It's going to do its operations as you normally do. And then again, if there's an issue, and again, we can play with stuff too. You can take that code and you can play with it. And what if I did this? What if I did that? And that's the idea. And that's what a QA person or tester is going to do. They're going to take your code and they're going to beat the crap out of it. Because that's what they should do. Because you want them to beat the crap out of it because when you get it out in production, that's what your users are going to do. The last thing you want is them to not be able to do it. And then here, what I was telling you before. So I'm going to go back a second. Here, you're just doing a system.out.println, and you're just putting your own text in there, just saying this is the message. Well, on the next one, it says, you know what? Instead of doing a generic message, let's actually tell them. And again, you got to know your audience. That's part of it too. Sorry. So you might get this message, and you may display this for certain users, like your base users. They might have no clue what the heck this even means. Even when you display the message, they may be like, I don't know, they'll call help desk or something like that. I don't know. again, depending on your audience, if you would want to put something out, you might want to stick with keeping it very generic. What some people do is they do two lines. They do one line for output to the user, like that, or and it tells a line number, something like that. And then what they do is they have a second line that the user doesn't see, where it does a write to the file. Oops.
System.out.println, mistake.getMessage,
Yes.
system.out.println, end of
Stop.
program.
Sorry about that. And what you can do is you can take this line and you can write this to a file. So then when the user calls and says, hey, I got this error message, blah, 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 you can say, can you do what? Can you go and get the audit file and let's find out what happened, the log file. And then they'll go find it, and whatever was the mistake or the error message that went in there will be in there for you. That's really handy, especially as a developer. A lot of times you can get it as a developer. I don't even have to talk to the user. I can just get it off the server. It'll write it to a server log somewhere. Like databases do that a lot of times if there's errors on a database. But I can get it right off the server and I don't even have to think about it. And boom, it's done. And I can look and see what's going on. Some systems, if you get more sophisticated, now think about this. Error comes up, you could have it where it emails you, right? It contacts you, it could text you, it could do anything like that. No different than these days. You have servers that talk to you. You have a problem with your server, it'll text you. We used to have it where we'd have hard drives on our servers. You'd have them set up like as a RAID. Maybe you had 5 disks in there, right? Five drives in there. And you could have one go down and it's okay. And then you could go and you could swap it out, put a new one in there, and rebuild it. If you got two that go down at the same time, it's bad. But the reason I'm saying this is what will happen is one will go down and the system knows it, or even before it goes down, it would say, there may be a problem with this drive. It will send out a text message or it'll send an alert out to you. It's a system management software that does this. It's really nice. It tells you that. This is kind of after the fact. You got an error, something happened, boom. But again, there's all kinds of cool ways that you can do this, and you can do some of this stuff without the user even having to be super involved. Because you could be like on it like that. Hey, we got users that call. I know. I got the message. I'm already working on it. I already have a fix. What? Yeah, I got the message last night. It came through. I started looking at it right away. I knew it was going to be a problem. I think I have a fix for it, and we'll push it out in the morning. Dang, you get a raise. You're good. And that's the idea. You want to be as proactive as possible. You may not be able to figure it all out, or it may take you a little time, but at least you're not sitting there waiting for a whole bunch of users to start calling you, because that's the worst part. All of a sudden you get a call, hey, we have a user calling us. They're having a problem with this module. What's going on? I don't know. It's the first time I've heard about it. Half hour later, hey, we have another user with a problem with this module. Something's not right. Hey, we're getting all kinds of calls now. All of a sudden, your day is like ruined. Cuts you off guard, right? And what you thought was going to be a productive day has turned into a bug fix day, and you have to do it quickly to do that. Whereas you know about this, and it makes your manager happy because then you're on it, that kind of thing. Again, nothing is perfect, and it still might take you time to figure it out how to fix it, but it's something to think about. So again, like I was saying, not to repeat myself, but I'm going to repeat myself. Something like this is really nice to tell the user, and that's fine. Please call tech support. There was an arithmetic line number. You can even tell them and have it on a screenshot so when they see it, they can get that. And then in this case, again, you have another line that maybe prints out. Now it doesn't do the system out. It just does a write to a log. You have a log file that we did before with the text files that then displays the message. So something like those two things together are very handy. Trust me, I know what they speak. Again, you get the divide by 0 error there. So those are really kind of nice. Let's do this. Okay, yeah, that's fine. Let's just check on, make sure I checked all that. Actually, I want to. So in the catch that we've been looking at, I like this much better looking at this than looking at the PowerPoints. The PowerPoints are driving me crazy. So the catch to everything we've been doing is just kind of displaying information, displaying messages. But guess what? You can do more. You can do more to catch than just display a message. You can do some other stuff. So I do a try. I've got my result, numerator, denominator, blah, very boring, right? Reason. But here in my catch, it caught some mistake, whatever the mistake was, right? So what they decide to do is they decide to take the results and then have the numerator divisible by 1, which you know will work, right? Anything divided by 1 is what? Itself. Just a simple math problem. But what it does is it says the program has continued here, its result to have a valid value. Does that mean it's going to have the value the user expects? Not necessarily. So you still may need to tell the user, this is you had a problem. You entered incorrect denominator, but it's a nice, elegant way of finishing it because it forces the value. It says, I'm going to make the result equal to this, and we're just going to keep going. And the program, then it does it. Because maybe further along the program, there's other pieces that it needs to do stuff. But you can automatically force feed it, for lack of a better term, a valid value. And they I talked about trying to make try blocks a little bit foolproof. Again, trying to circumvent user errors. And they have some examples. So let's do this. Let's look at the uDoIt here. A lot of stuff going on here. I'm going to go into JGrasp here. Give me a second. Okay. So we're going to do the exception demo. Okay. So I'm going to do File, New, Java. And we're going to do the exception demo. So we're going to use the Swing library. javax.swing.star. Okay. So we'll do the Swing library. Public class. And they're calling it exception demo. Open curly, close curly, close curly. Let me shrink this a little bit here. Oh, another good IDE out there is one called IntelliJ, if you've ever used it. Some students have used it. I've used it. It's really kind of nice. You can write a lot of Java with that. It's kind of cool. It's called IntelliJ. I forgot to tell you that as well. But again, the most common ones are NetBeans and Eclipse. So public static void main string args open curly close curly, and then I'm going to save it, and I'm probably going to overwrite my exception demo. Yep, I know it exists. Okay, so we're just going to do some simple stuff. We're going to create a numerator, denominator, and we're going to do some division. So int numerator, I'll even spell it out. Denominator. Now here's it. You know what? I'm just going to do this. I know it's den or den. How about denom? Start typing too long of words. Numer. Oh, the heck with it. Trying to make it smaller. It doesn't. The heck with it. I'll just do that. It just gets long. I'm going to copy and paste after that anyway. It doesn't matter. And then int result. Now they don't set result to anything, but I'm going to set result to 0. I like for 0 initializing everything else with 0. Why are we not going to do 0 result? And then we're going to have a string. And the string is input string. Like so. We want to initialize that. Okay. So what we can do is we can write some code to get some information, but I'm not going to do the try catch first. We're just going to do the code first. Because you might have other code you might run into. So I'm going to say input string is equal to j option thing show input dialog. You want to get information from the user. Enter a number to be divided. Okay. So it's going to ask you to enter a number to be divided. Let me make this smaller here. Okay. All right. So we're going to answer into it. And then numerator is going to be whatever value I get. Now I'm getting a string, And remember, numerator is an int, so I have to parse it, right? So I have to do the parsing of it. So I have to do integer.parse int, and I have to get whatever it is. So in this case, it's input string, which is right here, and just paste that in there. So it's just going to parse that value, and it's going to turn whatever that is into an integer. So I have my denominator. Guess what? Now we're going to do the denominator, right? Well, I am not going to just type that whole thing. I'm going to copy and paste. Just remember, one of the biggest issues with copy and paste is you always forget to change stuff. So this one is enter a number to divide into, you know what? Let's do this. Enter a, what would you say enter a denominator? I'm not writing that big sentence out. And then the same thing with this one. Just copy denominator up there, down here. There we go. I'm going to change this to enter a numerator. And I think they're afraid that people aren't going to understand what that means. So I'm just going to say enter a numerator, blah, 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 enter numerator. Sorry about that. You can leave it however you have it. So I'm going to get that. Denominator is going to parse that. Again, I have a string, and that's going to be there, like so. And then the result is going to equal what? The result is going to equal numerator, copy, paste, divided by denominator. So we're just going to play with this a little bit. We're going to get some errors, and then we're going to try and fix the errors. All right. So that's all the code. Let's build it. Usually I like to build it before, but I didn't do that because I'm a little lazy. All right. So built. Let's run it. Numerator, denominator, everything built, compiled. Okay, enter numerator. I don't know. So this is the one on top. I'll say 10. Denominator on the bottom is 2. Okay. Nothing to get spit out. I forgot to do that. That's the one thing I forgot. So we don't get our result. So let me go back into the code. Sorry about that. And we're going to spit it out in a display. So JOption main show message dialog. Null. So now it's going to be, they have you do all this stuff. I'm not going to do it. I'm just going to say result equals like so. Result. I'm not going to type all the other jibber jabber. You don't have to. It's too much. Too many concatenators and slashes and all that. You're welcome to, but you don't have to. Let's build this again, make sure it works. Let's try. There we go. Let's run it again. All right. So you always put stuff in that you know is going to work, right? So I'll do 10, and then I'll do a 2. It should be 5, right? Result is 5. Yay. All right. Now for the fun one. Let's do one we know is going to break it. Let's do 10, and then I'll do a denominator of 0. There it is, right? The old arithmetic exception error. All right. So again, we could change it so that before they enter denominator, we could say if denominator is equal, or we could do this. If it's equal to 0, we could say please re-enter it. And you can put a little while loop. You can do all kinds of fancy stuff. Or we can do what we're talking about now, is we're going to wrap this all with a try catch. Now, some of the other editors are much cooler than this one. Whereas what you can do is you can literally take all of this, and then you can go up here and you can do an insert, and you can insert the try catch around it. We're not so lucky. So we just have to do this. Try, open curly brace. Then I'm going to do is highlight this whole section, and then hit my tab key, and it's just going to tab over. And then I'm going to go back over here and then close it. Just like that. So you indent it. And then I'm going to hit enter, and now I'm going to do my catch. And then you get to do the catch of the fun exception. So this is going to be, I'm catching arithmetic exceptions. There are a number of exceptions. We can look them up too to see all the different exceptions. This one's arithmetic, and then exception. like so. And the catch, again, it's just like it's a separate piece of code. And again, I can take this and I can display, again, the message, JOption pane dot show message dialog. In this case, we're just going to actually, we're using this is what's returned, this exception is what gets returned. And then that, you do get messages, the actual method. And they also have you set result equal to 0. Just to clean that up, like so. So I have a try, open, close right there. There's my try, my catch. This whole block right there. And then I have my catch, and I open and close that right there. Everything's closed up. Let's compile it. What did I miss? Can I find symbol? Ding, ding, ding. Catch with reception. Can I find symbol? 27. I do. Thank you. It's funny. It's like it's right there and you still can't see it. Thank you. Extra G's. Too many extra G's. Okay. They were on sale, so I got 2 of them. All right. Anyway. My mom used to go to the store and she'd come home with this load of stuff. You'd be like, well, what? Did you need all that? Well, she said it was on sale. Okay. Why did you get it? Was on sale. Sorry. Anyway. Numerator. Let's do a 10. Let's do a 0. So it did it nice. It did so the message is actually slash is divide by 0. That's slash by 0, divide by 0. That's your message. Again, you can do something like this, and for a programmer or whatever, this is fine. I don't know, again, if I have a user would really understand what this is, and that's why I'm suggesting that you probably wouldn't want to just throw this out to a user. You could, because again, if you have a tech support person on the other end, they're saying, well, what is it giving you? Well, when I do it, I run it, and I enter 10, and then enter 0. It says slash by 0. Now, the tech support person potentially should know what that means. But again, the more information you can provide, the better. So you'd want to actually say divide by 0 and blah, 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 whatever. You'd want to be very obvious about it. But that is, in a nutshell, I mean, that is the basics of it. If anything you remember from this whole exception handling chapter, to be honest with you, bless you, is how to capture some of these errors. And they get more sophisticated times too. It gets much more sophisticated, but this is the most basic. So the code that you run that didn't change at all. That's still the same code. I would normally run that. And we've been running code. So I can take a try catch block and I could wrap every piece of code we've written and it would be fine. In fact, you'd want to do something. Ideally, you want to do something like this through any piece of code you ever write. Which is funny because now you're saying, well, we've written all this code and I have never done it right because we just wanted you to understand writing the code and all that. Now it's like now you're getting more advanced and like how do I make sure I don't get these errors, or how do I handle these errors appropriately, right? So again, you just wrap it all with a try and catch, and it's so simple. Like I said, with this, and there's multiple ways you can do it. Again, this one you'd probably also want to write to a file to do that, but it just makes your life so much easier than having something crazy show up. And again, you always want to run it to make sure that it still works fine, right? Result is 5, and everything works. So even with some odd numbers or things like that, everything still works. So what if I do a 10 and I divide it by a 100 or 1,000? I get a result of 0. Okay, things like that. So we're playing with integers versus decimals, that kind of thing. So it didn't. Well, and that's a good question. So if you want to, if I do an A, boom. So I entered an A instead of a number, right? So guess what exception it picked up? So we're searching for, so I entered an A, and it's looking for an arithmetic exception. And this time it came up with a number format exception. So you can specifically pull up exception errors that you're looking for specifically, or you can do a generic one where it just takes any exception that comes up. So it would catch everything. It just depends on how detailed you want. So I can do another one here if I wanted to. I can literally do this. I can do another catch, and I can do number format exception. I believe I can just do this. Type it right. Let's try it. And number format exception, let's do this. Let's see if this works. And then I run it. And this time I'll do an A again. Input string A. So it caught it. It did it. So again, you could do each one. I could keep going. But then you're like, well, geez, that means everything. And it just depends how detailed you want to get. Or again, you could do like a catch-all of just catching any exception. And you can do something like that. I think earlier in the chapter, it just did this. So here, I can change this while we're doing this. Let's just do this. So what I'm going to do is, you don't have to do this. I'm going to take this, and I'm going to just comment this out. So right now I'm going to just do this, and I'm going to just change this from arithmetic exception just to exception. Okay, and I'm going to just change this from exception to just like an E like that. And I'm going to change this to just to make it really obvious. Let's see what happens. So it should catch anything. And so we'll do the ones we did before that we know work. So I'm going to enter a 10, and I'll do a 2. So that works. And then I'll do it again. This time I'll do a 10, and I'll do a 0. It caught that. And I'll do an A, and it caught that. So it kind of a catch-all. Again, it just depends on what you're doing. If you want to be very specific about it, you can do that versus the specifics versus, or just a generic, you can do that as well. So highlight a couple of things here. Where is it? Let's see, demo. We just walked through that demo. Different divide by. So again, they have examples. They show us again different scenarios. I just showed you again. We can use the generic exception class, or like in this case, they have different exceptions. They have another one in here called the input mismatch exception. So you can have all kinds of exceptions. It just depends on what you want to catch. And there's nothing wrong with having multiples, like you just saw me do. We can do that. It'll catch everything, which is kind of nice. Just how specific you want to do it. So again, and they show you here, well, you might get this exception, or you might get this exception, or whatever. So again, it's kind of nice to be able to do that, to narrow it down. In my opinion, to be honest with you, and again, it's totally up to you as a programmer of what you want to do. But if you can do, the more you want to do, I mean, I could do the big one, I could do these. What you could do is you could actually do these other ones, the arithmetic and then the number format exception, and then you could do the generic one at the bottom of that. So if you want to find this, get the specific one, you could do that, and then you can still do that. So I mean, you can always have that one as a catch-all if you really wanted to. You could do that. It just depends. Different options for what you want to do. And it's kind of showing you again different The idea, and I'll reiterate it again and again, is you want to somehow elegantly either get out of the program and end it gracefully so the user can potentially call support or whatever the case may be, or if possible, how that we did some of the code, or in some of the code it showed you where we actually said a result is equal to 0. You want to somehow at least come up with something that's not going to blow it up and it finishes. It may not give the user a result they expect. Hey, I got a result of 0. Well, why is that? Well, you got an exception, and so it just set it to that default. So there's nothing wrong with doing that. It's just being aware of what's going on. Again, the users are going to be oblivious. They are, as they generally are. I did something. I don't know. I just hit some key. I don't know. I used to get errors all the time from users. What'd you do? I don't know. I just typing. What are you typing? I don't know. Numbers and letters. I don't know. What are you working on? Give me a screen. Give me something. It's like talking to a 5-year-old, right? It's just like, geez. Can you be a little bit more specific? There he was, standing on a hill. Anyway, sorry, I digress. Details. Give me details. I need details. So this is all good stuff. Life easier as a developer, as a programmer. And I keep saying those interchangeably because they are. They talk about some cases about unreachable. You might have unreachable statements that never execute. That's fine. So here, if for example, if two successive catch blocks catch an arithmetic exception and an ordinary exception respectively, the arithmetic exception causes the first catch to execute and the other types will fall through. So, and again, that's fine. There's no, again, if you can catch it somehow, that's good because there's so much bad code out there. And I shouldn't say bad code. It's just there's code out there that just isn't written to catch a lot of this stuff, and that causes some issues. It can wreak havoc. And this is the one we said. So this exception will just catch everything. It's the catch that handle all types of exceptions. So and then it's generic. Operation was unsuccessful. You didn't do it right. Something happened, right? Something was wrong. I'm sorry, there was a problem there, ma'am. So let's just try to figure out what it is. The other ones you're trying to be more detailed if you can. Again, does it matter? Not necessarily. I think most people would be very happy if you had something that caught the error versus didn't catch the error. That's really kind of nice. That's the main message you want to take. All right, so you've got your catch block, you've got that, like I said. Again, you've got the different cases. Now you can also do it this way also, where they do a catch this way, where you have it as two extra parameters. So I could do a catch arithmetic exception, or input mismatch exception. So you could do it that way as well. There's nothing wrong with it. It still will throw it, and then you can use E, and then you could do that E.getMessage, how we did it, and it'll still display it. There's nothing wrong with that. That works fine. But it's just, again, another way of doing it. All right, so let's do this demo 2 here, because it's kind of the next step there. So let's do that. I got a lot of extra code in here, but that's okay. And this one's not very long. So I'm going to change this to exception demo 2. And I'm going to do a save as. I'll save it as 2. And I'm going to overwrite mine because I already have it. Okay. So what they want me to do is, let's get the program we did that. Because I was playing with stuff. So I'm going to have to change my code back to get it back. So I'm going to change my code. I'm going to get rid of this again. And then I'm going to put it back the way you guys had it. I'm going to do that, and I'm going to edit and uncomment. There we go. And then let me make sure I run this and make sure this still runs okay. Make sure I didn't screw up something. Dust again. Okay. Go down. Okay, so that works, and then I'll run this, and let's do the numerator, and I'll say L10, and then I'll say 0 again, and okay, I get my divide by 0, that works fine. That looks good. Oh, and then let's run it again, and then if I enter an A, I get the error there too. Okay, so it does catch that. Yay, okay. So now they want to do, oh, because you know what? How do we leave it? Yeah. I'm not supposed to have this in here either. We already did it actually. That's all they want. So demo 2 wants you to do this piece of it here, this number format exception, but we're going to add some extra line. We're going to add some extra time. So instead of doing this message dialog, we're going to do that. But then I'm going to, instead of doing this exception here, under here, I'm going to change this, and they're going to put in this specific message that says this application accepts digits only. Hey, digits only. Okay. And then it's actually gonna, you're gonna reset the value. So numerator is gonna equal 999, equal 999. Denominator is gonna equal 999. And the result is gonna equal 1. We're gonna leave the other stuff there. So, and then I'm going to build this. So same thing. So catch number format exception, right? Okay. And it's gonna set the numerator 999, denominator result is 0. Okay, so let's compile it. Already did that. Let's run it. And we'll do what we did before. I'm just going to enter a letter A. And that's nice. And that's a nicer message than the other message that I had, the generic, the exception.get message that came out. That tells, only accept. Again, think about it. You're on an application. It says last name must be 30 characters, up to 30 characters, or first name, or birth date. If you're entering data, it's going to ask you, it's going to tell you, you can only enter this type of data, that type of thing. It's very helpful, especially to the user, and they'll fix it themselves typically. They'll make adjustments accordingly, and that's it. And so they're saying, confirm the program works appropriately whether you have usable integers, an unusable zero, or a non-integer strings. And we've been doing that. So again, you always want to make sure that with correct data, it works, which it does. So I enter 10 and a 5. The annoying thing is I have to keep running this, but that's okay. 10 and a 0. I get my divide by 0 error. And again, back to the other one. So let's do this. I'll do the numerator, I'll do 10, but the denominator is an A. Same thing. So it works, it catches it either way. If I do it in the numerator or denominator, it does catch that character versus a digit, which is good. Because it would be bad if it only caught it one. And again, and that's the whole idea. Because otherwise, if I was going to do this manually, think about it. I would have to put an if statement after this. They enter the numerator. I have to put an if statement there. If numerator is it a digit, or is it a number, whatever, or is it a character? If it's not a digit, boom, I don't want it. I have to do the same thing at the, stuff like that. So the try catch eliminates a lot of those issues. It just makes it much cleaner, much nicer, because it catches everything that way, just the name, right? I'm going to try this code. If it doesn't work, I'm going to catch these errors, is basically what it's saying. I guess I could record this again. So we're taking exceptions and we're putting this into NetBeans. Why am I getting that? It's not used. Okay, so you're going to get warnings. It's not used. That's fine. Not used. That's fine. Okay, now let's run it. So we're going to run it. Enter a numerator. So you're saying if I do 0 by 0, you're getting infinity? So 10 by 0. I still get the divide by 0. And for those of you who are wondering online why I'm doing this, is one of our students said he was getting different results in NetBeans versus in JGrasp. And so I just wanted to make sure that I wasn't losing my mind. Well, I am losing my mind, but that's a different story altogether. Let's try it again. What if I just do 0 by 0? Still does it. What if I do just, oh, what? What did I do? Why am I getting error all of a sudden? Sorry. Oh, I hit I hit a 0. Thank you. Thank you. Let's try it again. Clean and build. Clean and build. It builds. And let's run it. I guess I just do F6, right? So this time I'll do, oh, A. Let's do an A. I don't know. I mean, it seems to behave similarly in NetBeans as in JGrasp. It's all you. So if you're writing out to log files and then it blows up, the files are still open. And that's the problem. That's what they're saying here. And then that causes problems. Are there ways to fix that? Yeah, but it's a pain in the butt because it thinks it's open, which means you can't, when you try to run the program again, and it's going to try and reopen something that's open, it says, ain't going to happen. So it won't let you do it, which is really frustrating. So then you got to go in, and half the time what you usually have to do sometimes is just close the application. Or so I've even had to reboot sometimes. I've played with the attributes on a file. I played with it to read, write, all that. It just becomes a headache. So sometimes the easiest thing, it gets messed up in memory, is I sometimes will just reboot, comes back up, everything's cleared, and I'm done, and I start over again. So it can be a real hassle, and that's happened before. So the finally block, again, is the last thing. In this case, they're showing you, here, try open a file, read some information, do some calculations, blah, blah, blah. Hey, we're going to catch any errors that come up, right? If you do catch it, blah, 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 it does it. Finally, it'll do it after the catch. It's still going to, if the file is still open, let's close it. So it's, again, a nice way of closing things up. It's kind of like garbage collection in coding. And not catching stuff. So that's actually really kind of nice. And I don't know if the PowerPoint had talked about some of that. There was the multiple exceptions. There's a finally block. So again, user for actions that must perform at the end of the try catch, cleanup tasks, and no matter what, it will always execute, which is really kind of nice. It helps you clean up some stuff. And they give you, the sample example there. If you don't have stuff that has to be executed, like our code here, it doesn't have, there's nothing really earth-shaking that if once you get to here and then if you hit a catch, boom, I don't have to have there's really no need for a finally in this because there's nothing that I have to clean up or anything like that. And I don't have any files open, anything like that. So I don't really need it there. So I could, but I don't really need it there. So again, when the try code fails, again, it throws the exception. The exception object is caught. And the catch block execute. It passes control to that part of the program. Is all that's going on there. Da, 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 da. And they kind of give you reasons why statements might never execute. So again, an unplanned exception. That's kind of a misnomer. Because I mean, obviously, if it's an exception, it's probably unplanned. You didn't plan for it to happen. That's why you have it. The try or catch may have a system exit. Some people, they're like, you know what, if you get to this point and you have a problem, you have an error, just get out of it, just stop the application. You're done. Finito. No more. No mas. Right? System.exit. It is not elegant and it's not great, but you might have a reason for doing it. You don't want them to continue on for whatever reason. And again, like we were playing with, the try block may throw something, an exception that you didn't catch. So if you didn't catch it, there's another way you can do that. And then again, it's going to abandon that method. Again, you can't think of everything. The code that we did before, with the not in this one, but the exception demo, which I commented out. Where is it? Exception demo. This is the story of an exception demo. There you go. The exception, just a general exception handling class, which catches everything. Again, your question is probably like, well, why don't I do that all the time for everything? Because it literally catches everything, and you might again maybe want something really specific, or you don't care about some other stuff that comes out. All you care about is certain, so different things. Okay. So again, when the finally block is used, try ends normally, catch executes, and then again, the exception causes the method to abandon prematurely. So it's kind of nice. Some of the advantages, the book talks about these. Understand the advantages. Hopefully, again, having things end nicely, not blowing up on you, all that kind of stuff. And before a lot of this, before the classes, and like I said, you could have code. I could do this, and I'd have to like an if statement, right? The book kind of showed you. I could say, a user could enter a numerator, and I can then go in here and I have to say if it is num numerator, blah blah blah, go like that, blah 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 blah. I'd have to do that for the numerator. I'd have to do that for the denominator. I'd have to then do that for result. I mean, each piece. Can you still do that? Yeah, you can still do that. And sometimes you may have to do stuff like that in your code anyway. And guess what? Can you nest try blocks within each other? Yes, you can. So I can have one try block and I can put another one inside there if I'm executing other code. So I might get into some code here, do some stuff, and then inside here, I may do something like connect to a database. Get some data out of a database, something like that, right? And a big issue sometimes with doing that is, who knows, there could be permissions issues, the database might not be there. It's like going to a file. You can have all kinds of weird, wacky stuff happens when you connect to a database. So connecting to a database is something that you normally would have in its own try block all the time. You say, hey, if I can, what most users do is and you're going to get into this in other programming classes, is connecting to a database is a huge thing. And normally what you do is, most applications have it set up as when an application is initialized, is you try to connect to the database right at the beginning. Why? Because sometimes your application isn't really going to do much if it can't connect to the database. So again, think about it. You go on your in terms of this, if you go on your computer and you've got to do some work online and you have no internet connection, you're kind of dead in the water, right? There's not a lot you can do, right? So right off the bat, boom! Oh, I don't even have a connection to a Wi-Fi connection. I don't have an internet connection. I've got nothing. I can't do what I need to do. I have to work offline or whatever. So some applications are set up in a way where you can still connect and do what you need to do even if you're not online. There's a software that we use when I worked for the sheriff's office in Lake County. Think about it. You're in a car, you're going around, and they've got their laptops and they're doing stuff. And as they drive through the counties, just like we do up here, you hit dead spots, right? Or poor signals. And, hey, I got 5 bars. Hey, I got 3 bars. Hey, I got 1 bar. No, I got 5 bars. It's all over the place. It varies. Imagine you're on an application and they're out in their field doing stuff. They're looking up stuff. They're searching for stuff, whatever the case may be. And then they're doing stuff and they're driving and they lose, they're in the middle of doing something. They drive. They lose connectivity. There was an application that was set up below the application layer. And if you guys know about the different layers, you've got the operating system. In a nutshell, you've got your computer, which is the hardware. It's got the BIOS that runs all the basic hardware stuff like that. Then you got the operating system on there. So Windows is running stuff. On top of the operating system is the application layer. It runs applications. So it'll run a Java application, Microsoft Office, all those types of applications. Right below the application layer, they created this so that it would intercept any issues with connectivity, and it would fake the application or your computer out thinking that it was still connected. Because a lot of applications, when they weren't connected, what happens? They would time out, and then they would be logged out of their system. And that can be really frustrating. So they're out there in the field, they're working, and this is for anybody, not just this. You're out in the field working, get distracted, you're in the middle of doing something, you go to drive somewhere, walk somewhere, all of a sudden you lose your connection. They all of a sudden have to log back in and start all over again. And that was a big pain. So this application was really kind of cool. It kept it kind of in suspended animation. It let them keep working as if they were connected. And then when they did establish their real connection back again, it would just pick up left off. So they could finish up what they were doing, then upload or whatever. It was really kind of cool. There's other applications out there that did this. I can't remember the name of the vendor that did this, but it was huge. Because the vendor, the deputies, the sheriff, they were like, and we had people who would go in the field, inspectors, doing inspections on property, like that. They'd be like, I'm out there in the field doing stuff, and half the time I have a connection, half the time I don't. I spend more time logging into the application than actually doing my work. And so that was a frustration. So this was an application that solved that problem. Kind of crazy, but it's such a niche, but it worked. So anyway. So I kind of digress, but what I was getting to again with this is connecting to a database is kind of a big deal. So a lot of times you'll put this at the beginning of your application to make sure that, hey, I can connect, or things like that. You also have to give an option to, this is a little off topic, but you have to give an option to your users to maybe use something offline. And I don't know if you've seen, a lot of times I'll see that applications, I go into it, if there's my connection's not bad or I'm not connected, maybe I'm in Bukuville, then it'll say, do you want to connect offline? And it does give me some limited functionality, but I can still do some stuff. At least I can still do some stuff. And then when I get back into an area where I have coverage, internet access, then it just, oh, you're connected. Okay, here you go. Let's update everything. So just a thought, just something to think about. So again, and then again ties into some of this too, because again, as a programmer, you're trying to account for everything you possibly can, and you just can't. You're not going to think of everything, and you can't drive yourself crazy doing that. So before this, like I was saying, the application's purpose and intended outcome are lost in a maze of if statements, just like I was saying. Coding mistakes are made because of complicated nesting. And that's what I was saying. I could have a whole bunch of if statements. If this is a value, a numerator, I get this. If the value is between 1 and whatever, this is okay. If it's a 0, so I have all these if statements. It could be a nightmare. It could be a real headache. And that's how the coding was always written before. You had no choice because you didn't have things like this exception class set up. It's awesome. Languages have become so much more powerful to do stuff. It's really kind of cool. So, again, in this case, talking about calling method A, I call method A. If it worked, hey, I can do some stuff. If it didn't, I can then set an error code. If A worked, let's do B. Okay, hey, if B worked, I'm good. I'm going to keep going, right? And everything is good. So you have the stacked method. So I'm sure there's tons of systems out there that if you do one part of it, of the system, if you get a certain part of the application, so you're filling out an application for a loan, right? You can't get anywhere. And I'm kind of out of my skis on this, but you probably can't get very far unless you enter basic stuff like your name, your address, and maybe your birth date, maybe your social security number, because it needs to know this stuff. Is that right? Okay. So you enter this basic information, and once I get that and it has it, it'll take me to the next step. I've got this information. Now I'm going to start checking stuff, some basic stuff. Online, on TV, I don't know if you've seen ads all the time. They've got those ads for like Rocket Mortgage and all those different things to get loans and all that. Or they will get you verified in minutes. And that's how they're doing this stuff. You're entering information and it's connecting to all these different databases, trying to find out, okay, who are you? Is your name valid? Are you valid? Is your social security number valid? Your birthday? It checks all that stuff out, make sure everything is cool, and then it keeps going to the next step. And that's what that's all this is saying here. Kind of saying a lot of that same stuff. Again, with the try and catches, this is kind of nicer. So you got the nested calls, if. This is kind of messy. But look how nice this is with the try and catch, right? Do a try, it's going to do each method. And then if any one of them throws an exception, it handles it accordingly. So you could have one for each method. Method A, method B, method C, because each one may be specific. Hey, you didn't enter your personnel information properly. Hey, you didn't do this properly, whatever. So you can really customize the errors that come out with these for A, B, C. And that's some of the really nice advantages of this. And again, you might miss something here. You might miss a curly brace, or even if it's all the coding is correct, you might miss something. It's a big headache. But that's, again, how it used to, back in my day, that's how we used to do things. Back on the farm. Again, the idea is making sure the programs do what it's supposed to do, the actual real job, what it's doing. That's all this is saying. And hopefully the language is supposed to hopefully help some of that. Okay. Specifying the exceptions that a method can throw. And we've done you can have a method that can throw exceptions too. So when you create a method, when you have a method, you can add to it or whatever, and you can have it throw exceptions depending on what you want to do. So right now we've done methods. We've done a lot of our own methods. Display menu, display this, do that, but they're not doing any exceptions. But you can have it do that. So they're going to show you an example here. Where is it? I'm not going to show you to there. They're going to show you in the book here, which I'm going to go to in a second here. I like it, just show you that. I like that. 2 truths and a lie. So there we are, the method A, method B. But the other part here, so right here, this is kind of important. And you'll see this in code all the time. So they have a method here called display price. Got my variable set up. I've got a method display price, and it's only displaying price. But they added on there, it's going to throw an index out of bounds exception on that, right? So the first program, it's going to display that it's got that price list set up, and it's going to display that. But with the throws clause, it's going to throw an exception if something, if there's an issue with it, right? Again, it just depends. It just depends on what you're going to do, how you want to do it. And that's what they're talking about here. If a method throws an exception that will not catch, but they have a different method will catch it, you must create a throws clause. A throws clause by using the keyword throws followed by it. And that's kind of nice. So again, with that method, it'll do that. I'll pause everything here. Yeah, so here, again, here's your static void. Here's getting information from the user, enter a number, blah, blah, blah. Let's do a try, price, list. It's going to display price. Again, so when you call this method and you pass that parameter, the item, if there's an issue, it's going to throw it, and that's the exception that it's going to throw, right? Because you saw that earlier. And then it's going to then, by default, say the price is 0. So when you're calling, I'm trying something, I'm calling a method. In this case, the method is then going to throw the exception. So it's not necessarily the line of code, it's the method itself that's actually going to, that's what's going on there. That's why they're doing it like that. That's kind of nice and that's kind of helpful. Also, you can do it this way, where again, you have the same try, you're calling the method again, but again, this way, you can change it and you can call, even with the exception, you can call it again, but then you can use the max item, which is a constant, in this case of 3. So you can have it set default, kind of like how we did before with the catch classes, where you can set a default of a certain value, a certain number, to do it that way. So hopefully that makes sense. The book is going to get into much more details about some of this stuff. You can read it. I don't have to go through with you. The only other thing I want to talk about, NetBeans will kind of take you through stuff, and it's just, again, the call stack is, again, it's locations in memory where it's showing you how it's processing stuff, what's going on. And when the method throws an exception, it throws it up to the next call stack, and that's what happens. So I don't know if they show you. So it's kind of giving you an idea here how this works. So operating system, we call method A, which calls method B calls C throws an exception. Can it be caught here? No. And it goes, where can it be caught? Blah, blah, blah. So you're cycling through the stack of where you're going to catch it. All it means is you need to know where something happened. That's it. That's all it really is. It's the call stack is about where something happened. And then you can actually print this out. You can do what's called stack trace, and you can print this out. Again, other languages have different ways of doing it. If you ever hear someone say, did you ever look at your call stack or your print stack? That's what's going on. Your call stack is how things were called, what was called, when was it called. It's amazing how sometimes you think things were called in certain ways, but it may not have been. Like, I thought I was doing this, or I thought I was doing that, and it didn't do it the way potentially you thought it was. So here they show you actually in the book is a nice example. I was going to go back to that one really quick here. I like this one. So it shows you here is the code where you're in method A, method B, method C, and then boom, something happens, and then it shows you demo stack. It shows you 21, 15, each place where something happened and it ended. So again, you can actually and spend all your time just going through exceptions and I'm not going to bore you with that. If you can just get a handle on it, get a handle on your own code, because again, what I'm going to say is a lot of times what happens is you get thrown into someone else's code. You can also create your own exception classes, which we're not going to do, but you can read that. What I'll just say is you can, a lot of times, especially as a new developer, you go to a place and they're going to throw you on existing code. They're just going to say, can you go, there's a problem with this, can you fix it? Or can you add something to this code? And what you want to do is you want to learn the code as best you can, as quickly as you can, so you understand the systems of what's going on. And then if you make a change, you got to understand what you're changing. But again, it's understanding, debugging what you're doing. It's hard to learn, and that's practice. And don't freak out about it. I mean, for those of you who haven't done it, I know some of you have, some of you haven't. Just, it's hard sometimes to debug code that's not your own because you have no clue. Because first of all, you got to read through it and understand what it's doing, right? And they may use variables and ways of programming that you have not seen before. Once you figured out what they're doing, you're like, okay, is this correct? So syntactically, it may be correct, right? You may compile, it may build, but maybe it gives the wrong result. Or maybe it doesn't give the result that they want anymore. They want to change it. So you have to figure some of that out. Or it may just generate a bug, an error in certain circumstances. You know what? If we input data, it takes a double, but if you enter something to the 1000th decimal place, it creates a problem, right? So if I enter 10.01, it's fine, but if I enter 10.001, it chokes or whatever, Why does it do that? I don't know. Let's figure it out. And maybe there's just a way the calculation happened in the algorithm. So stuff like that you got to figure out. And I do this, we've done this in class where I will just create print statements, all of it. And that's a simple way of doing it. Sometimes it's not the easiest, but doing these exceptions and stuff, trying to figure some of that can be very helpful to you. So just kind of my 2 cents. Debugging will be your key. You want to get really comfortable with that. And again, we haven't played a lot with NetBeans, but NetBeans has ways of doing that too. It's much more sophisticated, and you can trace variables. You can watch when variables change. So I have a variable, like say I have numerator. I can watch and see every time numerator changes. Show me. Some reason or result keeps coming up with the wrong result. And I know I enter a numerator of 10 and a denominator of 2, and it should be 5, and it's not coming up with 5. What's going on here? And you can trace it, and you can say, okay, show me result. And it'll show you result is 0, result is 0, and then all of a sudden it changed. Line number 22, it changed, or whatever, 23, it changed. Why did it change? Okay, so maybe you made some incorrect calculations. So there's stuff like that. So, all right, I promised you I would